Okay, well I couldn't do the 10A, so I guess we're here doing the AMC instead to make up for that. I'm not ready for this. I'm still using my trackpad to write. That's wonderful. And yeah, it's only a 40-minute test. That kind of makes me anxious. Let's go. Where's the value of... Okay, let me try to go fast. So 34 minus 16, which is D, 18. A square piece of paper is folded twice into 4 equal quarters as shown below, then cut along the dashed line. Okay, it should just be E, I think. Wind chill is a measure of how cold people feel when exposed. Okay, so you just plug it into the formula. 36 minus 18 times 0.7. 1.8 times 7. That's 12.6. 36 minus 12.6. 23.4. So B. Okay. I think we're just going to have to fill this one out. I'll just, okay. 8, 9, 10, 11, 12, 13, 14, 9, 10, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47. Only 3 of these are prime, so it's a D. Okay. A lake contains 250 trout along with a variety of other fish when a marine biologist catches and releases. Okay, so this is just doing $250 over x equals 1/6. So 1/6, so 250 is 1/6 of, 250 times 6 is 1500, so it's B. The digits 2, 0, 2, 3 are placed in the expression below 1 digit per box. What is the maximum value of this expression? Okay, well you can't put 0 in the base, so 0 has to be an exponent, and then you don't want to use a very valuable one on that, so you can do 2 to 3, or 3 to 2, 3 to 2, so you do 9, and yeah, it looks like it's C. So far, not too bad. A rectangle with sides parallel to the x-axis and y-axis has opposite vertices. How many points on the rectangle lie on at least one of the 2 lines? Okay, sure. Let's see what we can do. This line looks like okay, it looks like it doesn't pass through. This one looks like it will. Well, let me check. Wait, it should be 3 over. 3 over. What? Here, I'll just do it like this. 3 over, 3 over, 3 over, 3 over, 3 over. Okay, so it hits the corner. So it's B. This is C. Low. Okay, wait. Each player competed against each of the other 3 players exactly twice. So you just find the missing one in each one, right? So zero, 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 one, zero, 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 one, zero, one. Let's see. Malaika is skiing on a mountain between 4 and 7 meters. So 4 and 7 is this. And then we do, so it's these two, these 4, and these 2. So 2 plus 4 plus 2 is 8. B. Harold made a plum pie. He was only able to eat 1/4 and he left the rest for his friends. The moose came by and ate 1/3. Okay, so it's 3/4 times 4 and 9, so 2/3 squared. 3/4 times, right, times 4 and 9, so this is 1/3. So it's a D. This is 10. I should get out of red. NASA's Perseverance rover was launched. What are these numbers? Okay. It landed on Mars, 6.5 months. Okay, so miles per hour. So we have miles and we want to find hours, and we do powers of 10, so we're doing scientific notation. 1, 2, 3, 4, 5, 6, 7, 8. We're on 1, 2, 3, 4, 5, 6, 7, 8. So 3.0 times 10 to the 8, approximately. This will be a bit bigger, but yeah. And the 6.5 months, 6.5 times 30, we'll write as 3 times 10. Times the number of hours in a day is 24. These will cancel with this, and this will become 10 to the 7. Okay, now what? Now 24 times 6 is 144, I think. Yeah, 144, and then you add a 12, so it becomes 156. So that's 15.6. Wait, no. It's not 15.6, it's 156. 156. And 156 is 1.56 times 10 to the 2, so 10 to the 5 over 1.56. So it's something times 10 to the 4. It's like a little bit above half times 10 to the 4. So. Six times 10 to the 3, no, it should be 6 times, so it's C. Okay, well, the figure below shows a large circle. What fraction is shaded of the interior large circle? So each of these are radius half, so it's 3/4 pi. So we can just drop the pi, it will cancel out later. 3/4 plus, this is 4 pi minus pi, so it's 4 pi, wait, yeah, so it's 2, and then you divide by 9, 3/4, so this is 8/4, so this is 11/4, and then it's B, cool, this is 12. Along the route of the bicycle race, 7 water stations are evenly spaced Between the start and finish lines are shown in the figure below. There are 2 repair stations. Third water station. Okay, we're calling each of these x. So 8x is the entire thing, right? And you know, the third water station is 3x, then minus 2 is the first repair station, so 8x over 3. So 9x minus 6 equals 8x, so x is 6. So 8x is 54. Wait, no, sorry, 8x is 8 times 6, which is 48. The D. Nicholas is planning to send a package for an Anton. 5 cent, 10 cent, 25 cent with exactly 20 of each type. What is the greatest number of stamps Nicholas can use to make exactly 710 postage? So we're trying to make 710, so we do this greedily, right? So 5 times 20 first, because we only have 20 of each type. That makes it 610, and then you do 25 times 20. Or no, we're doing 10 times 20 actually. So far we have 310 left, right? Because this is 100, this is actually no. 100 plus 200 is 300, and we have 410 left. And then we do 400, we can do 25 times 16, which is 400, so 16, I'll just do 25 times 16. But then we have 10 left. We have 10 left, and we need to get more room for 10, so we flip it into 25s. 25 times 2 is 50, so we can remove 5 of these. So we get 15 here. And 2 more here, so instead of 16 here, you get 18. And then you can take up the remaining 10 here with 16. So it's 20 plus 16 plus 18. 16 plus 18 is 34, so it's 54 D. Okay, this one walks half a mile to get to school each day. His route consists of 10 city walks of equal length, and he takes 1 minute to walk each block. Okay, he takes a detour. From the time he takes, what speed must he walk? So it's half a mile. Okay, we'll do this in terms of blocks first, right? So how many? So normally he walks 10 blocks, and so it takes him 10 minutes because it's 1 minute per block. So he walks the first 5 blocks, that's 5 minutes, and then he only has 5 minutes left. In 5 minutes, he has to get how many blocks? 1, 2, 3, 4, 5, 6, 7. So 7 blocks in 5 minutes. 7 blocks. Each block is... Okay, wait. So 7 blocks in 5 minutes. Each minute is 1/60th of an hour, because we're doing miles per hour ultimately, and then 7 blocks is... how many miles? 7, so half a mile is 10 blocks is half a mile, so each one is 1/20th. This is 1/2 divided by 10, so this is 3 up here, so 21 divided by 5, which is 4.2. Letters PQR are entered into the 20 by 20 table. Okay, what's the pattern here? PQR, and then QRP, PQ, RPQ, PQR, QRP. Okay, so I'll just do the first 3 columns first, and then, okay, wait, so it's 20 by 20, right? So 20 is 6 times 3 plus 2. So we have 2 remaining. So we'll do whatever we get in the first 3 columns times 6 plus 2 extra of the first 2 columns. So in the first column, what do we have? We have PQR. So we have PQRs, we have 6 of each at first, right? Let's do that. Let's do this PQR. We have 6 of each at first. And then at the end, what do you have remaining? You have, because it's PUR, you only have P and Q remaining, right? That's the first. And then you have QRP, QRP, so you have 6 of each again, and then you only have Q and R. And then in the third one, what do you have? You have RP, you have RPQ, so you have R and P. Okay, this is the first 3 things, so this is 7, or no, 6 times 3, which is 18, 19, 20. 6 times 3, 19, 20. So there are 20 of each at first. So there will be 20 of each at first, and then you do 20 times 6, which is 120 of each. So 120, 120, 120. And then you only look at the first 2. So in the first 2, what do you have? You have 13, 14, 13. So it should be 133, 134, 133. That's C. And 16. We have 9 left. We have 23 minutes. We're cruising to a regular octahedron. Okay, I'm seeing a floating problem. I don't want to do it. I'm skipping it for now. We're going back to this later. This is going to take a while for me to visualize. 18. Grasshopper sits on a long line. Okay, 5 to the right or 3 to the left. What is the fewest number of jumps? So 2023. So we have to do 2023 divided by 5 because we want to low-key greedy, but not really. So 2023. 4. This will become 0, and then you drop the 2. This becomes a 0. Then you drop the 3. This becomes a 4. And you get 3 left, right? So it's 404 times 5 plus 3. Okay, and then one way to, so you want to get this. Another way you can do this is 405 times 5 plus, or no, not plus, minus 2. Minus 2 we can get from doing 3 times 2, right? Minus 3 times 2 because we're going to the left, plus 5 times 1. So we can do 405, or no, this will give you minus 1, right? And then you do this again, so really this should be double it here. Right, because this will give you minus 2, so that's 6. So you can do 411, but that is on the higher end. Can we do better? Can we do 409, for example? Like, what if we do this one, right? 404 times 5. There's probably a way to do this with an equation, honestly, that I'm just not seeing. 404 times 5. Plus 3. Okay, so 400. How do you get a plus 3 out of this? Because, okay, each time, so you do 5x minus 3y, right? What kinds of differences can you make out of this thing that are close to, like, reasonable, right? If you had a plus 2, then you're chilling because you only have to do 1 of each, for example. Or if you get a minus 3, you're chilling. If you're getting 5, you're also chilling. So can we write this with a minus 3? Potentially. 406 times 5 minus 7. No. Minus 3 won't work. Okay. Can you get it with a 5? What if you do, okay, no, you can't get it with a 5 because then it'll just be divisible, right? Can you go with a 2, because you're going +2. This is the best that we can do. We can only do 3 and -2 because after this, what happens is we have like 407 times 5, I mean no, 406 times 5 minus 7, and getting -7 out of this. Wait, if you want a -7 out of this, right? You can get that actually. You can do 5 times 3, which is 15, minus 3 times, no, wait, hold on. 5 times 2, which is 10, minus, oh wait, I'm doing this backwards, hold on. You can do 5, I think you need 3 times 3, which is 9. 3 times 4, actually 3 times 4. 5 times 1, 3 times, so 5 minus 12 is -7. So 1, 4, 5. That gets us back to 411. I feel like 411 really is the answer then. No matter what you do, I feel like you end up at 411. 403 times 5 plus, what is 8? Yeah. Then you have the same problem, right? Because you do 5 times 3 or 5 times 4, which is 20 minus. You can definitely prove this with like modular arithmetic or something, but I don't want to do it right now. 4. Because all of these differences, right? All of these differences have to be 3 mod 5. All of these differences have to be 3 mod 5, right? So -3 is, the -3y is congruent to 3 mod 5, that means y is congruent to -1 mod 5, which means y is congruent to 4 mod 5, so y is, yeah, so y is at least 4, right? Y is congruent to 4 mod 5, no matter what. And that's what we have here, and that's what we have here. So if y is 4, what happens? You have 5x minus 12. 5x minus 12. What can you build from that? You can build, if it's a 1, you can build -7. If it's a 2, you can build a -2. Then 3. Just all of these things, right? Like 8 next. We only have 15 minutes left. We should really speed this up. I'm convinced it's 411, honestly. Because you have to go up a multiple, you have to travel up this thing greedily by a multiple 5 to get in the like vicinity of that, and then intuitively what happens is, in order to actually get like the difference, in order to actually get in order to end up at the exact location, we just prove that it has to be 4 mod 5. So You have at least 4 moves like that, and the rest is handled by moves of 5. But like, because the moves of 5 is just like, that just depends on how close in the vicinity you already got there. It has to be 411. Like, yeah, okay. 19. An equilateral triangle is placed in a large. Okay, so they're 2 equilateral triangles. What is the ratio of the area of one trapezoid? Oh, so you just find the difference of that and then you divide by 3. Sure. S squared root 3 over 4 is the thing, right? Okay, S squared root 3. The side length of the inner is 2/3 of the side length of the larger, so S squared root 3 over 4. Where the larger thing is. Then you just have 2/3 squared times the same thing. And then you divide by 3 for one of these things, and then you divide by the, okay, to the area of the inner triangle, right? So you divide by 2/3 S squared root 3 over 4. Looks like this cancels out. So you have 1 minus 4/9, which is 5/9. You have 2/3 here. You have 2. Why am I getting 5/18? 1 trapezoid to the area of the inner. How am I getting 5/18? That's not. Okay. Let's do this again. Okay, we saw that the thing cancels out, so in reality I'm just using A. So we have A minus 2/3 squared A, so 4/9 A. Alright, that's the difference, and then you divide by 3 for each trapezoid, and then you divide this by the area of the inner trapezoid, which is, the area of the inner triangle, which is 4/9. Oh, okay, maybe that's why. I'm dumb. I'm actually so dumb. Oh my god. We're dividing by 4/9, so this is the same thing as multiplying this by 9/4. Wait. I'm actually confusing myself so bad right now. There should be 9 up here. Yeah. And then this becomes a 3. So 3 times this thing over 4. The A's don't matter anymore. This is 5/9. 3/4 times 5/9. Okay, it's 5/12. Thank God. Okay. 2 integers are inserted into the list to double its range. The mode and median remain unchanged. What is the maximum possible sum of the 2 additional numbers? I do not want to do this. To double its range, 2 integers are inserted into the list. 3. To double its range, what's the range right now? It's 25, so it should become 50. The mode and the median remain unchanged, so you have to add 1 to each side. The mode is 3. The median is 8. So you have to add 1 to each side of the median. And you want to make the range 50. So you have to add something to the top. And you have to add something to the bottom. So you have to make this a 2, and you have to make this a what makes that to, or okay, 52. Wait. There's something wrong here. The mode. Wait, the range right now is 25, right? You want to double it, so it's 50. Oh. You don't make this the smallest one, you make this 53. Okay. You make this 53, and you make this as large as you can without, so you make this 7. So it's a D. Wow, they were nice. They could have made that a trick choice. Alice writes, use to divide them. This looks like a combinatorics problem. Is there anything easy right now? 22 looks not too bad. Each term, okay, yeah. Let's bash this. A, B squared, AB to the, or I mean A squared B to the 3rd, A cubed B to the 5th. This is 1, 2, 3, 4, 5, 6. This is 4,000. Okay, yeah, so 4,000 is 10 cubed times 4. 4 is 2 squared. 10 is 2, so 2 cubed times 5 cubed. So it's 2 to the 5th times 5 to the 3. So B is 2, A is 5. The first term is 5, it's D. Okay, we're doing geometry next. Did I number that one? Yeah. Okay, isosceles triangle ABC is equal side lengths. What is the height of ABC? Okay. What did I just do? Oh, okay, H is the input. Oh, they have the same area. So this is H minus 5. This is H minus 11. Oh, it's isosceles. Okay, that's also useful. I should read the entire thing. A, B, and BC are the same. So all of these things are isosceles actually. Do you have any base areas, or I mean base lengths? Oh, these are the same exact triangle. Okay. Yeah, okay. This looks like the Pythagorean theorem to me. I don't know if I have time for that right now. What else? Can I do any of these other ones? Each square in a 3x3 grid is randomly filled with one of the 4 gray and white tiles. A large diamond in one of the smaller 2x2 grids. Oh, is it just? Okay, wait. How many 2x2 grids are there in that? It's a different problem. Are there just 3? There should just be 3. Because, okay, those, I mean, no, 4. They're 4. They're 4 and all of them are the same. So you do 4 times something. So 1/4 times 1/4 times 1/4 times 1/4. One-fourth squared, or I mean 1/4 to the 4. So it's 1/4 cubed, which is 1/64, I think. I'm doing this very quickly, so I don't know if it's true, but hopefully. What else do we have left? We have 21 left. 21's probably easy, but I'm skipping it. I don't know why. The height, h. I feel like there's something very obvious that I'm missing here, but I'm not doing it right now. The sum is the same, so 9 times 10 over 2 is 45. So 45 over 3 is 15. You want 15, 15, 15. 3 groups of 3 cards. Okay, so 9. You can add up any 2 and get a third that you need, so. Okay, I know I have a solid approach for all of these remaining problems, I think, but I don't have enough time to actually do it. We also have this one. This one is how do you do this? how do you fold this thing into an octahedron? So the square base is not, like, the square base is not present, so you have to fold the, okay, time is up. Let's see how I did, and then maybe we can go through some of the rest. I don't know if we have time. I think I can trust Anarchy for this. I hope I did not fail, but I don't know. I think I did pretty bad on the timing towards the end, so it is what it is. D, E, B, D, B, 6 is C, 7 is B, 8 is A, 9 is B, 10 is D, 11 is C, 12 is B, 13 is D, 14 is, really? 14 is E. What was 14? Really? You... Wait, I'm confused. How is that possible? Did I miscount something? Let's redo it, right? So, what was the problem? So you need, so initially you have 20 of each type, so you do 5 times 20. This gives you the first 100, so you knock it down to 610, right? And then you do 10 times 20. This gives you, so this gives you 300, so you have 410, and then you do as much as you can to 400, so you do 25 times 16, which is 400. 25 times 16 is 400, right? I'm not trolling. 25 times 8 is... Yeah, 25 times 8 is 200, so this should be 400, and then you have 10 left, right? In order to make 10, you switch out 2 of these. So first you switch out 2 of these, and then you have to add 5. Wait, I'm confused now. Oh wait, I did this the wrong way. Okay. Damn, okay. I think what I need to do is 10 times, I should have made this 15. That's what I should have done. This is supposed to be 15, and then this is supposed to be 18. And then this is supposed to be, and then after that you add the thing. Wait, is this still wrong? Oh, okay. This is asking for the greatest number of stems Nicholas can use. Okay, that's very dumb of me, actually. So the catch here, in case you didn't notice, is instead of using 16, you basically trade down to 20, because like the 2 that I switched out just now, you should be doing it in 5s instead, or you should be doing it in you can switch up some of the 5s into this, and then what you end up, so let me do that, right? So you have 16 10s, so you want to make it 20 10s. Wait, you have 16 10s. Let's just redo it from the beginning, from this point, just to show you what I mean. 20, and then you have 300, right? So you need 400 more, so you do this, and you have 10 left. But now what you need to do is you need to say, okay, I need to make 10. So first what I do is I need to look at 5, I need to look at 25, and then like the minimum that I can shave off to get some extra space here is I can trade in 125, right? So I can make this, instead of 16, I can make it 17, and then I get 5 extra spaces here, and that will make this 15 instead. And now once I have those 5 extra spaces, then what I do is I make this 17. Wait, I'm still getting 54, am I not? Okay, I'm doing something really stupid here. They use 17 quarters, yes. And they used how many? How many nickels and how many dimes did they use? Oh, okay. And then you want, so what you do is you also make this 19. And make this 19. And that does it, yeah. And you can't do any better than this because you have both of them as close to 20 as you possibly can do. Okay, that was a tricky one. I did not think that through, I guess. That's pretty bad. I'm not gonna lie, that's pretty bad. Okay, 15 is B. 16 is C. 17 I did not do. Wait, did I really? 17 was the octahedron one then? Yeah. Okay, just for completeness, let's look at how to do that, because without like visualizing, fast and cheap. 2, 3, 4, 5 make the bottom half. See, this is what I was having trouble with, realizing that this makes the bottom half of the octahedron. The only way you can really do this is visualize how you fold it, which I did not want to do, so. Okay. Grayed out grasshopper. Okay, this is D. See, I'm getting all the more hard ones right, and then I'm getting the easy ones wrong, which is, I mean, I got one of the easy ones wrong, which is not like easy. I mean, which is not good. But yeah. 18 was D. 19 was C. 20 was D. I did 22. 22 was D, yeah. 23 was C, yeah. Cool. That's pretty much it. So let's see how many I did. I don't know. Should I just, okay, you know what I'm going to do? One thing that I forgot to do that I should be doing is I should be guessing C for all the remaining ones. I'm not looking at the answer choices in terms of I guess, but from what I remember, the AMC does not penalize guessing, so you have to guess, or I mean the AMCA does not penalize guessing, so you have to guess the remaining ones. So I'm just putting C for all the remaining ones that I didn't do. Right. So we're going to pretend like I just put C for all of them, for the remaining ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 17 we're putting C because we did not. Okay, and that's wrong because 17's A. Fair enough. 18, 19, 20, 21 we're putting C. Okay, I got 21 right as well, so I'm adding that in. We'll move it up here. 21 C, right. 22 is D. 23. Oh, 23 I'm guessing C as well. Yeah, 23 C. Oh, I'm actually getting some guesses right. This is wonderful. 23 C, right. 24 I'm guessing C as well. Okay, it's A, so that's wrong. 25 is A. I didn't do 25. Okay, I think this is it. I guess 24, right? Yeah, okay. 23. Let's see how many I did correct now based on all of that. So 1, 2, 3, 4. Wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. 14, 15, 16, 17, 18, 19, 20, 21, 22. Okay, I got 22 out of 25. That is not the best that I could do. I think in terms of timing, I really started choking towards the end when I got to like this area here. The beginning we were kind of cruising through it, and yeah, I should have really attempted some of them. I mean, I should have really attempted 25, for example. It doesn't seem too bad. Okay, so that's pretty much all for the test. In terms of my review of it, I would say it's kind of feels like problems 1 through maybe like 14 or 15 of an AMC 10, plus like just some random things, honestly. Yeah, honestly, yeah, like to 14 maybe, and then with just like very odd, very contrived feeling odd questions. Like my least favorite question on this was probably where is it? This one right over here, because the number crunching was not it. You had to do some rounding and things. This is a common trend on the AMC 8, I think. They usually have some sort of estimation question. And then in terms of the other things, they weren't too bad. This one was also kind of annoying. Maybe there was a faster way than what I did, but yeah. And then this one wasn't too bad. I actually thought this was fine for an AMC 8. You kind of learned something. This one looks way harder than it actually is. It's pretty free, in my opinion. And then this is a geometry, I guess. Like, if there was more time to do it, I would have done it. But yeah, this is, from what I can tell, this looks like an arithmetic progression type thing with inequalities. Maybe I should have attempted it, but I just didn't have the time because I don't know. I think I was being crunched by the time. But yeah, 22 out of 25 compared to my AMC 12 performance of 123, getting 22 out of 25 on this. I don't know if that's very comparable, but I guess I just suck at time crunchy tests like this. But yeah, that's pretty much it. USAMO is coming up in around a month, so, or I guess not even a month. It's only a matter of a couple of weeks now, so I'll try to put out some musical videos before the season starts in December. But in case I don't get to do, like, in case I don't get to it, I'll definitely be able to put them out by like the January contest, but I'll try to put some out. And there will be definitely be more coming up in the January like near the January contest as well. In terms of live solves, this is pretty much all I'm going to do. And yeah, I guess that's pretty much it. Thanks for watching.